Dear students, good evening and a warm welcome to CSAT Made Easy 2025 series, where we discuss the most exam specific questions and concepts from the angle of your CSAT paper of 25 year. I am Sachin Gopanal and our today's topic of discussion would be number system. For those who are watching the video for the first time, what we do in this lesson series is I take a PYQ, I reverse engineer it and decode the concept behind it and present the same in the form of questions. And we will begin with basic questions and understand basic concepts and gradually rise up to exam level questions. Once again, welcome, and we will begin with the first question. This is the first question. Let's read the question first. What is the rightmost digit in the value of 2 to the power of 20? Okay, what are they asking us? They are asking us, let's raise 2 to the power of 20. 2 into 2 into 2 into 2, like we shall multiply 2 with itself 20 times. That would be 19 times. So there will be 20 2's in total, and the final product that we get, what will be the rightmost digit of that number? Okay, how do we solve this? The concept behind this question is this. Look at this table. When you raise 2 to the power of 1, that is when you keep 2 as it is, the last digit is 2, 2 square is 4, 2 cube is 8, and 2 to the power of 4 is 16, and then 2 to the power of 5 is 32. But observe the last digits. It was 2486 here, then 2 to the power of 5 32, 2 to the power of 6 64, 2 to the power of 7 128, and 2 to the power of 8 256. Again you get the last digits to be 2486, 2486, 2486, and again you get 2486. So the last digit, they form a cyclicity. This is not unique for 2, this is applicable for all the numbers. Look at 3. For 3 it is 3971, and once again 3971, and once again 3971. Okay, 3971, 3971 and 3971, they are forming a cyclicity. Look at another example. Take 4 for example. It is 4 6, then 4 6, then 4 6 and 4 6. Here the cyclicity, it is happening with only 2 digits. The point is, when you raise 4 to the power of any number, as you go on increasing, the last digit will be 4 6 4 6 4 6 and 4 6. But observe here, the cyclicity for 2, it was happening at a period of 4 exponents, 1 2 3 4. For 3 it was 1 2 3 4. For 4 it is only 2. Then this 4 6, the cycle repeats. For 5 we consider the cycle to be only 1, because the last digit for 5 raised to anything, it is always 5, and this is applicable to all the digits from 1 to 9. The cycle length, it might vary, but they all follow some particular cycle. If you just Google it, you will find the cyclicity of each digit. However, there is no necessity to remember it. You can do it in the exam itself. Just write 4 to 5 exponents of the number and you will get the cyclicity. There is no need to remember it. Okay. Now let's use this concept and answer this question. 2 raised to 4, it would be 16, and 2 raised to 8, it would be 256, and 2 raised to 12, it would be 4096, and the last digit would be 666. So for every multiple of 4, when the power is a multiple of 4, that is equal to the cycle of the 2's exponents, the last digit is always 6. So 2 to the power of 4, it is last digit is 6, 2 to the power of 8, last digit is 6, 2 power 12, last digit would be 6, and 2 power 16, the last digit would be 6, and 2 power 20, the last digit would again be 6. So your answer would be Option A, 6. What about 2 to the power of 21? If they had asked you 2 to the power of 21, then we would repeat the cycle. After 6, what will be coming? 2, right? So 2 to the power of 21, the last digit of that number would be 2. 2 to the power of 22, it would be 4. 2 to the power of 23, it would be 8. And once again, 2 to the power of 24, it would be back to 6. Okay. Now you understood the concept and we got the answer to this question. The answer is option A, 6. Okay. Let's look at the next question. The next question, what is the rightmost digit in the value of 12 to the power of 20? The same concept remains here, the same concept. This is only to clarify to you that it is just not a single digit number. Whatever the number be, let's concentrate only on the last digit of that number. Just like 2 to the power of 1 is 2 and 4, 8, 6, the cycle, look at the cycle, 2, 4, 8, 6. The same applies for 12 also. It's 2, 4, 8, 6 and it is 2, 4, 8, 6 and once again it is 2, 4, 8, 6. So let it be 12 or 22 or 32 or 102 or 9902, it doesn't matter. If the last digit is 2, this cycle repeats for the last digit of the exponent. So just like 2 to the power of 20, it had a last digit of 6, 12 to the power of 20, it will have the same last digit. So your answer would be option A, 6 again. Okay. Now you understood the concept of cyclicity of last digits powers. Okay. Now let's look at the next question. What is the rightmost digit preceding the zeros in the value of 20 to the power of 22? Or 22? Yes, 20 to the power of 22. Okay. Now this is 0, right? So 20 to the power of 22, however much you raise, the last digit will be 0 itself. But they are not asking us to find the last digit. They are already telling us that in the end there will be some zeros and they are telling us to find the non-zero digit after the zeros are done with. For example, let's say this value will be something like this and 0, 0, 0, 0, 0. They are asking us to find this digit which is non-zero. Okay. How do we solve this one? I think you understood the question, right? The question says when you raise 20 to the power of 22, you will get some zeros and some non-zero digits. They are asking us to find the first non-zero digit after all the zeros from the right are done with. The rightmost digit preceding the zeros in the value of 2 to the power of 22. Okay. How do we solve this? This question is based on this concept. First, let's understand the concept. The exponents, this concept is just explains the properties of exponents. If a to the power of x into b to the power of x, multiplication of a power x and b power x is done, then the product we can express it as ab into whole to the power of x, right? Yes, and converse is also true. So ab whole to the power of x would be, we can divide it as, we can split it as a power x into b power x. So let's split this 20. 20 to the power of 20, it would have been 2 power 20 into 10 power 20. The same way, 20 to the power of 22, this is 2 into 10 to the power of 22, right? So we can express this as 2 to the power of 22 into 10 to the power of 22. Yes. So however much you multiply 10 with itself, however much times you multiply 10 with itself, 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1000, 10 to the power of 4 is 10,000. So this, it doesn't add any new digit to us, it will only add zeros to us. So what matters to us is only this 2 to the power of 22. What matters to us is only this 2 to the power of 22. And we know the cycle length of powers of 2, right? If 2 is raised 20 times, 2 to the power of 20, we know that 2 to the power of 20, the last digit would be what? It would be 6. And what is the cycle of powers of 2? It is 2, 4, 8, 6 and again 2, 4, 8, 6. Because 20 is divisible by 4, which is the length, cycle length of the cyclicity of 2. 2 to the power of 20, it would be 6. 2 to the power of 21, the last digit would be 2, and 2 to the power of 22, the last digit would be 4. So this value, it would be something ultimately 4 into 10 to the power of 22. Yes, this would be 2 to the power of 22. It would have a last digit as 4, and we will express 10 to the power of 22 as it is. So this 10 to the power of 22, it will not add any non-zero digit, it will just add zeros. So what is the rightmost digit? What is the rightmost digit preceding the zeros at the end of this number? It is 4. So what is your answer? Your answer is option B, 4. Okay, let's look at the next question. What is the rightmost digit preceding the zeros in the value of 20 raised to 20, 21 raised to 21, 22 raised to 22 and 23 raised to 23? Okay, and what is the concept behind this question? This is it. Look at this. 13 into 14, it is 182. Okay, what is 3 into 4? 3 into 4 would be 12. What is common between 3 into 4 and equals 12 and 13 into 14 equals 182? Whenever you multiply any two numbers with last digit being 3 and last digit being 4, the last digit of the product, it will always be 2. See here, 13 into 14, 3 into 4, so you get the last digit to be 2. Look here, 99 into 72, you get the last digit to be 8. 9 into 2, it is 18. Here also the last digit is 8. See here, 82 into 83, it is 6806. 2 into 3, it is 6. So last digit is 2, last digit is 3, and the last digit came to be 6. 6 into 4, 24. Yes, 6 into 4, 24. The last digit is 4, and you got the same. It is just not applicable for two numbers, it is applicable for any number of numbers. 2 into 3 into 4, 2 into 3 into 4, that would be 6 into 4, which would be 24. The last digit is 4, the last digit is 4. 96 into 97 into 98 into 99, 6 into 7 into 8 into 9, that would be 42 into 8 into 9. We need not multiply 42 with 8, just take the last digit. 2 into 8 it would be 2 into 8, that would be something 6, right? Because 2 into 8 is 16. Okay, we did this, then we did this, then something into 9. So what is 6 into 9? 6 into 9 is 54. The last digit is 4. So here the product, it would be the last digit, it would have a value of digit would be 4. See, 4. Yes. So when you multiply any number ending with 6, 7, 8 and 4 numbers ending with 6, 7, 8 and 9, you will get the product to be, the last digit to be 4 always. I think you understood this concept, right? The product, the last digit of the product, it is dependent on the last digit of the multiplicants that you used. Okay, based on this concept, we shall answer this question. How do we do that? Look at this expression once again. What is the rightmost digit preceding the zeros in the value of 20 raised to 20, 21 raised to 21, 22 raised to 22 and 23 raised to 23? Okay, let's evaluate each of the 4 terms one by one. 20 raised to 20, 21 raised to 21 and 22 raised to 22 and 23 raised to 23. 20 raised to 20. Okay, we shall split this one. I will tell you why. Because this is the only number which is contributing to the zeros. None of them they are adding zeros. This is the only number which is adding zeros to the final product. So we will split it. We will split it how? We learnt in the previous problem that we will split it into 2 to the power of 20 and 10 to the power of 20, and we need not split this one. Why? Because the last digit is 1 here, and the cyclicity of 1, it is the cycle, it has only one value which is 1. 21 into 21, the last digit will be 1, it is 441. 21 into 21 into 21, the last digit would be 1. 21 to the power of 4, 21 to the power of 5, 21 to the power of anything, the last digit will always be 1. So we can actually ignore this number, because whatever the rest of the numbers do, it will only contribute the last digit. It will not contribute anything to the last digit. This 21, it will not contribute anything to the last digit. Okay, and what about 22 to the power of 22? This will contribute which last number? Okay, this will contribute, the last digit is 2, and it is raised to 22. So we know that the cycle for 2, the length is 4, and what is the cycle? It is 2, 4, 8, 6, and again repeats 2, 4, 8 and 6. 2 to the power of 20, it would be 6. 2 to the power of 20, it would be 6, because 20, it is divisible by 4 and the cycle length is 4. Okay, 2 to the power of 21 would have last digit as 2, and 2 to the power of 22, it will have the last digit to be 4. The last digit of 22 to the power of 22, it would be 4. And what about the last digit of 23 to the power of 23? The last digit is 3, right? And what is the cycle of 3? 3, 9, 7, 1 and 3, 9, 7, 1. So the cycle length is 4. So 2 to the power of 23 to the power of 20, because 20 is divisible by 4, which is the length of this cycle, it will have 23 to the power of 20, it will have a last digit of 1, and 23 to the power of 21, 23 to the power of 22 and 23 to the power of 23, this will have a last digit of 7. Okay, and we know that this will have the last digit of 1, so no, it doesn't make any difference to us, and this only contributes zeros to us, so we will ignore this one. This contributes only zeros to us, so we will ignore this one. What about 2 to the power of 20? 2 to the power of 20, the cycle length is 4 and 20 is divisible by 4, so the last digit of 2 to the power of 20, it would be 6. Okay, now we need to look at these 4 numbers only, 6, 1, 4, 7. Why not this one? Because this is the number which is adding zeros to us in the end. They are asking us to look at that number which comes after zeros from the right hand. If you look at the numbers, the digits from the right hand, they are asking us to find the first non-zero digit from the right hand after all the zeros are done. So in effect, they are asking us to find the rightmost digit which comes after multiplying these 4 digits, right? So what is it? 6 into 1 into 4 into 7. 6 into 1, the last digit would be 6 into 4 into 7. 6 into 4, the last digit would be 4, because 6 4s are 24, the last digit would be 4, and 4 into 7, the last digit would be 8, because 4 into 7 would be 28. So ultimately the rightmost digit preceding the zeros in the right hand of this whole expression, it would be 8. So your answer will be option B, 8. Okay, I think now you got a good idea of this cyclicity concept. in number system. This I think this was the only question which you found to be a bit confusing. However, rewatch the video from the first question. I have discussed these concepts in the previous questions. I have built one concept upon another and I have arrived at this final question. Rewatch the video and understand the concept in each of the previous questions, then you will be able to answer this question also. Now it is time to go to your homework question. This question, it was asked in the 24-year paper. What is the rightmost digit preceding zeros in the value of 30 to the power of 30? We have answered a very similar question in this just a few minutes ago. I think you will be able to answer this one. Do answer this one and leave your answers in the comment section. We will discuss the solution to this in the next class. And now we shall answer the previous classes homework question. What was it? It was this one. It was based on the concept of HCF, highest common factor. Let's read the question once. A can X contains 399 liters of petrol and a can Y contains 532 liters of diesel. They are to be bottled in bottles of equal size so that whole of petrol and diesel would be separately bottled. The bottle capacity in terms of liters is an integer. How many different bottle sizes are possible? Okay, let's understand the question. They are telling us that they have 399 liters of petrol and 532 liters of diesel. Now they want to bottle them in separate bottles. However, they are asking us, they are telling us that the capacity of the bottle has to be equal for both petrol and diesel. How many such different capacities are possible? For example, the simplest example that we can take is 1 liter bottle. We can take 1 liter for 1 liter bottles to bottle both petrol and diesel. To bottle up all the petrol, we will need 399 bottles, and to bottle up all the diesel, we will need 532 bottles of diesel. Such way, can we use 2 liter bottle? No, because 399 is an odd number. Since it is an odd number, if we use 2 liter bottle, one of the bottle, it would not be filled to the complete, right? They are telling us the whole of petrol and diesel. So they want such numbers which will hold the petrol and diesel in equal capacity equal capacity bottles, and all the petrol and diesel are completely filled. So we need to use the concept of HCF. How do we answer this? First, we need to take the HCF of 399 and 532. Since the HCF, it would be a factor of 399 and 532, that number, it would divide 399 and 532. So that capacity of bottles, they would be sufficient to hold both of them. Also, the factors of those HCF, they can also divide these numbers, right? So they are also eligible to hold these bottles. Okay. After answering the question, you will understand this concept better. Let's find the HCF of 399 and 532 first. How do we calculate HCF? We write the numbers side by side. Then we will divide both of them by any common factor. Okay. Which common factor do they both of them have? Since this is an odd number, it is not divisible by 2, then 3, no, this one is not divisible by 3, 4, no, 5, no, 6, no, 7. I think both of them are divisible by 7 using the divisibility rule of 7. Okay, 7 5s are 35 and 4 remains, and 7 9s are 49. Okay, this is 7 7s are 49, 7 6 are 42. Okay, now do 59 and 76, do they have any common factor? Yes, both are divisible by 19. 19 7 would be 57, right? I made a mistake here. This would be 57. Yes. So now both are divisible by 19. 19 3s are 57 and 19 4s are 76. Okay. Do 3 and 4 have a common factor? No, right? So we will stop our factoring. We will stop our division here, and we will multiply these two numbers, and that will be our HCF. So what is our HCF? Our HCF would be 19 into 7, and that would be 9 7s are 63, 7 1s are, and it would be 133. So the HCF of 399 and 532, it is 133, and if you used a bottle of capacity 133 liter, it will hold 3 bottles of 133 liters, they will hold all the petrol, and 4 bottles of 133 these things, 133 capacity, they will hold all the 532 liters of diesel. However, because I will tell you, because 133 into 3, that would be 399, and 133 into 4, it would be 532. However, all the factors of 133, they will also be able to hold the petrol rate. What are the factors of 133? There is 1, we cannot not count 1. Then we found out that it is divisible by 7 and 19 also, 7, 19, and then 133 itself. And since these two are prime numbers, it doesn't have any other factor. It is a product of two prime numbers, so it does not have any other factors. So there are 4 numbers that will divide both 399 and 532. There are 4 numbers that will divide both 399 and 532, and you can use the bottles of this much capacity to hold both petrol and diesel. If you want to hold both of them in equal capacity bottles, you can use all 4 of them. So how many different types of how many different capacities of bottles you can use? You can use 4 different capacities of bottles. So your answer will be option B, 4. Okay, I hope that today's video, it was beneficial to you. If you like our classes, do watch our class regularly. We upload 1 episode every evening, and also share the YouTube link to this video with your friends on WhatsApp groups and Telegram groups. And I wish you all the best, and most of all, I wish you a very happy studying.